We see a problem here. A block weighing 1000 Newton rests over a block B which weighs 2000 Newton as shown in the figure. Block A is tied to a wall with horizontal string. The coefficient of friction between the block A and B is 1 by 4, and that between the block B and the floor is 1 by 3. What value of force P is required to create an impending motion if P is horizontal? If P acts 30° upwards to the horizontal. Here, we have to write the given data correctly for solving this problem. It is given that there are two blocks. Block A weighs 1000 Newton and it is above the block B, which is weight 2000 Newton. And the block A is tied to the horizontal wall. The coefficient of friction between the blocks is 1 by 4, and the block and the floor is 1 by 3. We have to draw the free body diagram of each block. First, we have to draw the free body diagram of block A and then block B. While drawing the free body diagram for block B, the weight of the block B acts perpendicular to the ground plane. The reaction force always perpendicular to the lying plane. Then the applied force is on the right side directions. Therefore, the frictional force will there at 2 points, 2 contact points. One is the block and the floor. The another one is between the blocks. So the friction force F2 over here, and the another friction force F1 over here, on the opposite direction of the applied force. The block's A's weight will be acting downwards, therefore the reaction force will be opposite direction for the block A. So the reaction force N1 over here. Likewise, we have to draw the free body diagram for block A. The block A cell weight will act perpendicular to the ground plane. The reaction force for the block A is perpendicular to the lying plane. Here, a rope is tied over here. Therefore, the tension acts on the left side. Therefore, the frictional force acts opposite to the tension F1. These are the free body diagrams. Before solving the problem, we have to know that where the minimum number of unknowns need to be found. From the figure, we are able to know that the minimum number of unknowns are there in the block A. So we have to consider the block A for solving initially. By considering the block A, by assuming the equilibrium condition, sigma Fv is equal to 0, we will get the equation as N1 minus 1000 is 1000. Therefore, the N1 is equal to 1000 Newton. We know that Fm is equal to mu into Nr. This is the equation for impending motion. Fm is equal to mu into Nr. Mu is nothing but the coefficient of friction, and we have identified the Nr value for this problem. So, by substituting the known values, we get the F1 as 250 Newton. The equation for sigma Fx, the horizontal component, F1 minus T is equal to 0. Therefore, T is equal to F1. The tension also 250 Newton. We get the values over here. Now we have to consider the block B. Writing the equations by considering the equilibrium condition, sigma Fv is equal to N2 acts perpendicularly upwards, therefore plus N2, N1 acts perpendicularly downwards, minus N1, and the weight of the block perpendicularly downwards, so minus 2000 is equal to 0. We identified the value for N1 in the above equation. By substituting the known values, we will get the N2 as 3000 Newton. Then we have to write down the equation for sigma Fh. Sigma Fh is equal to P1 minus F1 minus F2 is equal to 0. Here, F2 is equal to mu2 into N2. That mu2 is the given value 1 by 3. 1 by 3 into N2 value 3000. We'll get the F2 as 1000 Newton. By substituting the known values, we'll get the P value as 1250 Newton. Second condition. When the P is inclined at an angle of 30 degree, we have to identify the P value. Here we have to redraw the free body diagram once again for the block B. For the block B, the P force need to be resolved horizontally and vertically. For horizontal force, we will get at P cos 45. For vertical force, we will get as P cos 30. For vertical force, we will get P sin 30. P sin 30. While solving the equation, we have to consider those two forces for the block B. For block A, the values will be same as the previous problem. We'll get the F1 as 250 Newton and the T also will be of 250 Newton. While solving the problem for block B, we have to consider this vertically resolved and horizontally resolved. So N2 minus 2000 minus N1 plus P sin 30 is equal to 0. So we'll get the equation as N2 plus 0.5P is equal to 3000 by substituting value for N1. Similarly, for horizontal component, while resolving, we'll get the equation as P cos 30 minus F1 minus F2 is equal to 0. We'll get the equation as P cos 30 minus 250 minus 1000 0.5 by 3. Instead of F2, we can substitute the above equation and we get the P value as 1210.4 Newton by either solving two unknowns, two equations in the quadratic form by using calculator or by substituting the F2 value over here. We'll get the equation, one quadratic equation, and we can get the P value as 1210.4 Newton. Thank you.